That. Okay. So we have this, and then I usually like to do the chat. This one. Yes. Okay. So hopefully this doesn't have too terribly much going on. Okay, so I think we're finally where we need to be. So we'll just take some time. We'll do the best that we can. Let me see. Did I miss somebody? I know someone just came in. Did everybody get attendance credit? I thought I heard someone come in, but if not, so notice we're at the 15-minute mark. I don't know, but I'm not going to worry too much about it. I think this is set up properly. Okay. So some rules of engagement as we kind of go through the presentation. Sorry for the delay. That's just as quickly. So we got about 30 minutes, give or take, a few minutes, for us to kind of engage today. So as we kind of go through the presentation, if you have questions, I am monitoring the chat. You should be able to see the chat window. And I think I am streaming this on my channel. Let me check my notifications. Yes, this looks proper. So we are streaming live on YouTube. Let's be ready for exam 1 next week. It should open up on Wednesday. It'll be due next Saturday. Unlimited attempts, and then after next Saturday, I think it's a 10% late penalty, right? And it should be based on the first half of chapter 1. So today we're gonna move forward.
How many attempts?
I think it's unlimited attempts. Yeah. Okay. So hopefully, I kind of do that to see how my students respond. Some students take advantage of it. If everybody doesn't take advantage of it, I'll probably do it again. But if everybody does take advantage of it, then obviously I'm gonna start to dial it back some. But oftentimes, I don't think I've ever had a case where all the students take advantage of it. So I kind of just feel it out and see. I kind of go from there. But yeah, but I definitely encourage everybody to take advantage of it. Right? Like that's the recommendation. Okay, so we got 30 minutes, so we'll do the best that we can. Honestly, say I want this to go over 3 days. What's 42 divided by 3?
14.
Is it 14? Because it's what? 30 plus 12 is 42, right? How do we know if a number is divisible by 3? Anybody know the divisibility test for 3? Or in other words...
If you could factor 3 into that number, I think.
Close.
Or like multiply it by 3.
If the digits add up to a multiple of 3. So for instance, okay. The 42, what is the 4 plus the 2 adds up to what? 6. And so since 6 is a multiple of 3, 42 is divisible by 3. I don't know how somebody realized that, but somebody noticed it. I think the divisibility test for 5 is like how do you know if a number is divisible by 5?
Isn't it if the last digit is a 0 or a 5?
If it ends in a 0 or 5, what if it's divisible by 2?
Even number.
If it ends in an even number. So I think there is a divisibility test for 7. I don't know it offhand, but there is one. And I think there's a proof that says you can't go further. There might be 1 or 2 more divisibility tests. Somebody proved, again, I couldn't keep up with that one, but they proved that there were no divisibility tests for higher numbers. But that's a whole topic. That's an actual topic that people study. I'm not sure if I'm recalling that properly, but that's what I remember. Let's do like this. We don't need all of this. We can get rid of a lot of this, like that, like that, like that, like that. We're just gonna take that and dump it right here. Okay, that's fine. Okay. Don't start to kind of slow down. Okay. So as we go through the presentation, if you have questions. There it is. If you have questions, just type them into the chat. I am monitoring the chat. Okay. So section 1.3 are on functions. So I think we said 14. So we have what? We meet 4 times in a week. So That's why I was like, okay, maybe we can spread it out over 3 days, and then we'll use the fourth day as just like practice, and I think that'll be fine. So as long as we make it to like slide 14 today, that's more than enough. Then we can spread it out over 3 days. Section 1.3 functions. We want to use function notation and find function values. We want to find the domain of a function, identify the graph of a function, get information about a function from its graph, and solve a few applied problems using functions. So, yeah. Definitions, we have a special relationship such as y equals 10x, in which each element x in one set there corresponds a unique element y in another is called a function. So in other words, every x corresponds to exactly one y. Y is sometimes referred to as the dependent variable and x as the independent variable. Okay. So then we have the definition of a function. A function from a set x to a set y is a relation in which each element of x corresponds to one and only one element of y. So again, every x corresponds to exactly one y. We don't have one x corresponding to more than one y. The set x is the domain of the function, and the set of those elements of y that correspond or assign to elements of x is what's the range. So in other words, the domain is our set of inputs, and then the range is going to be our set of outputs. So as far as function notation, each x in the domain of f that corresponds to a unique y in the range. The number y is denoted by f of x right here. Okay, again, this is read f of x or f at x, right? So f of x is, this symbol is read f of x or f at x. Sometimes students that think that this is multiplication and they try to multiply the function by x. This is not multiplication. This is not multiplication. That's the function f evaluated at the value of x. We call f of x the value of f at the number x, and say that f assigns the f of x value to x. Okay, so hopefully that's okay. So functions can be defined by ordered pairs, tables and graphs, and equations. So determine whether each relation defines a function. So this is a list of ordered pairs, all right? If we had one x going to two different y's, so the simple explanation for here, if we have repeating x's, then this is not a function, okay? If we have repeating x's, this is not a function. So in either case A or case B, do we have repeating x's? For instance, if we look at this first one, what's our x value?
-1.
Okay. What's our x value for this one?
1.
Not for this one.
5.
5, right? Okay. So the x value is the first number in the ordered pair. Do either list A or list B, do either of those have repeating x's?
Yeah, A.
A has repeating x's. Which ones?
The first one and the last one, right?
So there's -1 and this -1 here, right? So the x value of -1 occurs twice. So we have repeating x's, so it's not a function. So part A would not be a function. Do we have any repeating x's in part B? No.
Oh.
So then part B is a function. All right. If we were to graph part A, we would have one point on top of the other, and it would fail the vertical line test. There we go. It would fail the vertical line test. So, so A should not be a function. So notice the domain is a set of inputs for part A, and the range is the set of outputs, but this is not a function because two ordered pairs have the same first component. So we have repeating x's, so it's not a function. Again, domain being the set of inputs, the range being the set of outputs, and this is a function because no two ordered pairs have the same first component. So in other words, no repeating x's. Okay. Determine whether y is a function of x for each equation. Okay, let me think about this one. There's no y there. Let me see how they explain it. Like the first one, there's no y. So, let me think about it. I feel like there should be a y somewhere. That's supposed to be, no. Why does it look different? 6x squared, so it looks like there's supposed to be 3y and not minus x. I knew it was missing something. So that looks like a typo. Determine whether y is a function of x. Let's see. Subtract. Yeah, I'm thinking that that's a typo. Yeah, that looks like a typo. Right here, it looks like there should have been a negative 3y. Because like when they start here, they have the y, and then we would basically solve for y. All right? So, let me see. Because I would add the 3y to both sides and subtract the 12. Basically, I would move this 12 this way and move this guy that way. And then we'll get this line. So yeah, I think the original just had a typo. And then divide both sides by 3, and we get this. Okay, so looking at this last line, what's the highest exponent on any variable in the last line?
2.
2. Can you tell me what kind of shape that's going to make? Begins with either a P or a Q.
Parabola?
It's going to make a parabola, right? This is a quadratic because the highest exponent is 2, so it's squared. So the graph is going to be a U-shaped graph. Which way is the graph going to open up? Is it going to open up, upward, or downward?
Upward, right?
Because why?
The coefficient is 2.
Not 2, but... So if we have a U-shaped graph, and even if we didn't know that, we can choose several values for x, find the corresponding y. We said it crosses at -4. So we're anticipating a graph that looks something like this. Will this pass or fail the vertical line test?
It will pass.
It will pass the vertical line test. No matter where we draw a vertical line, it'll touch the function once. If we can draw a vertical line and it touches it more than once, then it's not a function. And to generate this graph for right now, what we can do is choose several values of x, find the corresponding y. Okay. So then, if we solve for y in the second one, do you notice anything happening there? So in the second one, it looks like we have this y squared minus x squared equals 4. If we go to solve for y, I'm going to add that x squared to both sides. We'll have y squared equals x squared plus 4. How do we get rid of that squared? Take the what on both sides? If we're trying to get the y by itself,
Square root, right?
Square root. If we take the square root on both sides, then we're going to get y equals... did I write this proper, or am I missing something? Did I apply the square root properly, or am I missing something?
Looks good to me. I think you're good.
Okay, I am missing something. Can somebody... Pardon? Whenever we take square root, we have to include what symbol?
Would it be bacon? The also minus
Bacon? What's bacon?
Oh, it's like not the equal sign. It's the squiggly equal sign.
Oh. You talking about approximately equal to?
Yeah, that one.
I was like, it does look like bacon. That's too funny. I was like, what's bacon? No, whenever we do square root or whenever we do an even root, we have to include plus or minus. All right.
Cash in my stash. I don't know where the data come.
Okay. So, if we take square root and we have to include plus or minus, let's choose an x value. Let's see. Okay, for instance, say x is 2. When x is 2, what's the corresponding y for the green part? When x is 2, what's the corresponding y for the green part? So for instance, when x is 2, 2 squared, what's 2 squared?
4.
What's 4 plus 4?
8.
So then when x is 2, we have plus or minus the square root of 8. So we have 2 y values corresponding to 1 x value. Is that a function, yeah or nay?
I
So again, values corresponding to one x value. So then it's not a function. It's going to fail the vertical line test. It's going to be, we're going to have it where we, you know, we can draw a vertical line and it'll touch the graph once. That one, I think it's like a hyperboloid. I think it's like two parameters that go in the opposite direction. I think that's how that one looks. We could choose some x's and plot them. Maybe not. Maybe it should be a circle. Let's look at it. Even if we don't see the graph, that's okay. The main thing is we can find one x that corresponds to two different y's, mainly because of this plus or minus. So then we say it's not a function. Okay, I'm going to let that be. So let g be a function defined by this equation. Evaluate each of the following. Okay, this isn't too bad. So let's do it like this. I really want some space. Let me get some space for myself. What time is it? 4:30. Okay.
It's me cash in my stash, and I'm on my way to another one.
All right. So let's take this. Let's copy this actually. Cool. It's not showing that. Awesome. I need that to go, and I want to add a page. Oh my goodness, I'm right here. Add a page. Oh, I just missed it. Damn. Let's go like. I think it's this one. Insert. Okay, this is. Okay, cool. Like this. And let's go to view. Seamless. What's the time? Okay. All right, and then let's do like this, paper, like this. Okay. So g is going to be defined by this function. They want us to evaluate each of the following. So it looks like the original, our g of x should be x squared minus 6x plus 8. And then for instance, part A asks us to do g of 3. Okay. So what we want to do, first we're going to replace each x with a blank set of parentheses. So we have x squared minus 6x plus 8. Okay. So then we're going to replace each blank set of parentheses. We're going to plug in our number 3. Okay. So then we just crunch the number. It's like order of operations. I think that first one is 9 minus 18 plus 8. I think that's minus 1, right? Let's try B. That asks us to do g of negative 2. So we can actually, let me get a copy. Let me see. Oh no, I'm going to need all of this, but I don't need that. I don't need that. I don't need that. Okay, so the second one, do this one more time. Copy. So I think the second one is g of negative 2. Again, inside of each blank, we're going to plug in negative 2 and negative 2. So the blank set of parentheses helps us to keep track of our negatives. So it seems tedious, but it helps because without it, it's very easy to lose track of the negative signs. So then I think that becomes a positive 4 plus 12 plus 8. That's 20. That should be 24. That's the time. So then C asks for g of a half. Okay. So we put a half into each set of blank parentheses. I think the first one's going to be 1 by 4. Half of 6 is going to be 3. And stop me if anything is not clear. That's 5, 5 and a quarter. Then it's going to be 21 over 4. Okay, D. A plus 2. A plus 2. A plus 2. And A plus 2.
We keep it as a fraction. Could we use that?
Let's see. It really the instructions on these assignments are going to be specific, so it depends on whatever the instructions are. Say, so like if you put 5.25, that should be the same thing. It just depends on the instructions. Right now, it left it open, but like if we're taking the exam on Pearson, they're usually very specific about the form that they want it in. Does that answer your question? Okay. So then with this one, let's expand it and see what happens. What's the time? Okay. Oh, I see the chat. Okay. So if we expand it, the first, I'm going to just jump to the answer. So let me see. It's going to be a squared plus 4a plus 4 minus 6a minus 12 plus 8. Then if we combine like terms, we got a squared. 4 minus 6 is negative 2a. 4 minus 12 is negative 8. Plus 8 is 0. So then we get this. I think there's one more. X plus h. Ooh. Okay, x plus h.
Would that answer be accepted on Pearson?
I'm going to pull up the way that Pearson did it, and we're going to compare their results with ours. Let me do this last one, and then we'll compare. But it should be. I mean, and you'll know, like, once you start working them, you'll know how they want them. I think the last one was x plus h. Getting into the difference quotient. Okay. So then we're going to do x plus h, x plus h, x plus h. Sure, let's just keep going. So that's going to be x squared plus 2xh plus h squared minus 6x minus 6h plus 8. I think that's it for that one. Because there's no like terms. That one actually infringes on this one called the difference quotient. It's a concept in calculus that we start in college algebra. Okay, so let's compare what we got with the notes. Let me see. So for part A, negative 124. We see the negative 1. We see the 24. We see the 21 over 4. A squared minus 2a, and then you see that long expression from part E. Okay. Any other questions? Okay. Okay. So I'm going to say we stopped here on Monday. What's today? August 31st?
31st.
Oh no. 20. Oh, come on. 2020. So then I'm going to say on this one, start here. Start.
Where does the 2xh come from?
Okay. Give me just a moment. Start here Tuesday. September 1st, 2020. Okay. Okay. Let's see. You said the 2xh. So if we expand this out, right, we have x plus h squared. What does that mean for if you say something squared? What does that mean? So for instance,
X plus h. X plus.
right, we multiply it by itself twice. So if we were to write it all the way out, I think you would see it. All right. So you have x plus h times x plus h. So what technique are you using here to multiply this?
Distributed.
What's it called? Aluminum what?
Foil.
Foil, right? Oh no. So if we foil it out, you'll see it. So foil first times first is x squared. Outer times outer is xh. Inner times inner is also xh. And last times last is h squared. So then when we combine the two in the middle, that's where the 2xh comes from. Is that okay? Okay. All right. I really didn't want to keep you guys. Yeah, I didn't really want to keep you much longer than that. I'm going to go ahead. Let me go ahead and load a copy of this. I'm going to share. I want to send it to Box. The location, fall of 2020, to Morehouse. This is my Monday, Wednesday, this one, to the notes. Yeah, we're on 1.383. Oh, okay. Send Box, okay. So as soon as the bar finishes loading on my iPad, you'll get a copy of it. Did anybody want to ask any questions for the group or just any other questions in general? Okay, guys. If there aren't any other questions, I'll let you go. Enjoy the rest of your day, and I will see you all tomorrow, actually. Tomorrow, what, 3:50? Okay. See you guys.
Yeah. Have a nice day.
Okay.
Sir, see you later.
Thanks, sir.
Let's do like this. Oh my god, you're in the way. Hide.